So you're being asked, what is the discriminant? If we cast our mind back to the quadratic formula, that is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. If we have a graph of, let's say, y equals x squared plus 4x plus 7, then the number in front of x squared is a. The number in front of our x term, the coefficient, is plus 4, and that's b. And this number on the end here of this particular example, plus 7, well, that will be our c. And of course we have a at the bottom there also. So that's what we'd use for our a's, b's and c's. And this is to do with a quadratic graph. And this particular one is a positive x squared, so we draw a u-shaped graph. And we're trying to detect where it is on the graph. Is it above the x-axis, in which case it doesn't go through it, and therefore we'd say there were no solutions in that particular case? Or does it sit on the x-axis, in which case there would be one solution because it's touching the x-axis in one particular place? Or does it descend through it, in which case there would be two roots or solutions? So that's what we're trying to detect, and absolutely critical to that is something called the discriminant. And it's this thing under the square root sign, b squared minus 4ac. That is your discriminant, b squared minus 4ac. Now, if b squared minus 4ac is less than 0, this discriminant in here, if that's less than 0, then you're trying to find, in the quadratic formula, the square root of a number that's less than 0, the square root of a negative number. Now, if you try to find the square root of a negative number in your calculator, it will probably tell you a math error. That's the answer that you'll get, because it doesn't want to find the square root of a negative number, and the whole quadratic formula at that point falls to pieces. So we get no solutions for x. Now, of course, if we look at the graph, that is one of the outcomes potentially. If the graph is sat above, in this case, the x-axis, or away from the x-axis, it never goes through, then we would get no solutions. So what the discriminant is telling us on this occasion, b squared minus 4ac, if it's less than 0, we would be trying to find the square root of a negative number, no solutions, and therefore the graph of the function sits away from the x-axis, and we get no real solutions. Now, on the other hand, what if b squared minus 4ac equals 0? It's exactly 0. So if this b squared minus 4ac, the discriminant, is 0, we have the square root of 0 then. That's all right. That's 0. But on the top here, we'd just be adding 0 or taking away 0 from this and then dividing by 2a. So we'd only get one answer. So one real solution. And what would the graph look like then if we only got one solution? Well, the curve would be sat on the x-axis. The x-axis, in effect, would be a tangent to the curve, and we get one solution. Now, in the other scenario, b squared minus 4ac, the discriminant, might be greater than 0 or positive. Now, if we have a positive number under here, that's fine. We can find the square root of a positive number. Let's say it was 4 under here. Then we'd find the square root is 2. Then we'd be adding 2 or taking away 2 from this. And then dividing by the very same thing, 2a. And you can see that in that case, we get two answers, two solutions, two roots. And that will be a graph that goes through the x-axis in two separate places. So we get two real solutions. So to sum up, the discriminant is the b squared minus 4ac, and it can tell us exactly how many solutions, how many roots we can get from this quadratic curve. And in the case of y equals x squared plus 4x plus 7, then we have b squared, which would be 4 squared, which is 16, take away 4 times a, 4 times 1 is 4, times c, times 7 is 28. So can you see that in this particular case, we'd end up with a negative number for the discriminant, and therefore we would have a quadratic graph that sat something like that above the x-axis.